So we're all racing towards a renewable future, right? But there's this huge challenge. Where do you store all that energy? What if the perfect solution for a farm in California just isn't the right one for a factory in Kenya? Today, we're going to dig into a different kind of battery, one that could be an absolute game changer for the developing world. And you're probably seeing pictures like this more and more. Giant fields of batteries. These are usually the same lithium-ion tech that's in your phone, just scaled up, way up, to soak up all that solar and wind power. And they are absolutely critical for a stable grid, no doubt about it, but they're not the whole story. But here's the thing. What if the very technology we're betting the farm on has some serious limitations, especially in the parts of the world that need a clean energy revolution the most? Okay, so to really get why that matters, we need to zoom in on the specific energy challenges that a lot of developing economies are facing. It's not just about switching to green energy. It's about building a reliable system pretty much from scratch. Now, this chart, wow, this really tells a story, doesn't it? I mean, just look at these numbers. South Africa, 83% fossil fuels. Indonesia, 81%. India, 78%. Making the switch to renewables here isn't just a small step. It's a massive leap. And a leap that size is going to require an incredible amount of energy storage. And here's the real kicker. This whole energy transition is happening in places that are often dealing with really unreliable grids, and on top of that, extreme heat. Now, your standard batteries, the lithium-ion ones in our phones and cars, they really struggle in those kinds of conditions. So this is where our hero enters the story, you could say. It's a completely different kind of battery. It's called a flow battery, and it's built on a fundamentally different principle that might just be the perfect solution for these very specific challenges. So what on earth is a flow battery? Well, think of it like this. Instead of cramming everything into one solid box like a normal battery, a flow battery stores its energy outside in big tanks full of a special liquid called an electrolyte. Just by separating the power part from the energy part, the whole game changes. It's a simple idea, but trust me, it's revolutionary. All right, so here's the magic. You've got these two big tanks of liquid, a positive one and a negative one. Pumps push these liquids through a central stack of cells. Inside that stack, the liquids flow past each other, separated by just a thin membrane. And as they do, they swap ions. That exchange is what creates electricity. It's an elegant, simple, and incredibly powerful concept. And this is the absolute key difference, the big idea you need to get. With a lithium-ion battery, if you want more energy, you gotta buy more batteries. Simple as that. But with a flow battery, you just need bigger tanks and more of that liquid electrolyte. So you want to power a factory for 12 hours instead of 6? You don't need a whole new system, you just need a bigger tank. Now, this unique design isn't just clever for the sake of being clever, it brings some incredible advantages, especially when we talk about those harsh, hot conditions we mentioned earlier. Let's look at how this tech is basically custom-built for a hotter world. Just think about it. So many of the world's fastest-growing economies are also in its hottest regions. This map here of South and Southeast Asia, it's just covered in tropical and subtropical zones. And for a battery, that kind of relentless heat, it's the enemy. 50 degrees Celsius. I mean, let that sink in for a second. That's over 120 degrees Fahrenheit. And that's the ambient temperature these things can just operate in, no problem. Some of the newer ones can go even higher. They're literally built for the heat. Now let's put that side by side with what we're used to. Your standard lithium-ion battery starts to really struggle. Its performance just nosedives once you get above 35 Celsius, so about 95 Fahrenheit. To make them work in hot climates, you have to build these expensive, power-hungry air conditioning systems around them, which, kind of defeats the purpose. Flow batteries? They don't need any of that. And the hits just keep on coming. We're talking a lifespan of 20+ years, way longer than other tech. Because many of them use water-based liquids, the fire risk is way lower. Plus, and this is a huge deal for logistics, you can ship the batteries totally empty and safe and bring the liquid in separately. That's a massive advantage for remote areas. Okay, so the tech is a perfect fit, right? But the story gets even bigger, because what's truly transformative here is the economic opportunity. This isn't just about using the batteries, it's about building them. Take a look at this map. Think about something like a mine. They're often out in the middle of nowhere, completely off-grid or on a really shaky one. They need stable 24/7 power. They are a perfect early customer for this kind of long-duration storage when you pair it with solar. And when you actually run the numbers on market potential, it is just massive. This analysis points to countries like South Africa, Indonesia, and India as having this huge demand, driven by mining, by industry, and just the basic need for a reliable power grid. And this is probably the most important idea in this entire explainer. It's a direct quote from the Faraday Institution report we're looking at, and it's a big deal. The opportunity here isn't just to buy a solution from somewhere else, but to build one at home. So what does that actually mean, local manufacture? Let's look. On the left, you can see the guts of a single cell. Pretty simple parts, right? A frame, a membrane. On the right, you see how they all get stacked together, kind of like a high-tech sandwich, to make the power unit. The key takeaway is that assembling these is way less complex than making lithium-ion cells, which needs these insane, ultra-clean factories. This is still high-tech, but it's within reach. And think about what that means. You're creating skilled jobs locally. You're cutting down on crazy shipping and import costs. And maybe most importantly, you're building a brand new, homegrown, high-tech industry from the ground up. So when you add it all up, you've got the right tech for the right climate, a huge market, and you can build it locally. What you get is, it's way more than just a new battery. It's a recipe for a whole new way of thinking about energy. Here's the big picture idea. This tech allows nations to completely leapfrog the old 20th century model, the one with giant, polluting power plants and grids that stretch for thousands of miles and are super fragile. They can just jump straight to a modern, decentralized, and resilient system from day one. So what's the playbook here? It's really a three-step process. 1. You pair these batteries with all that amazing sun and wind to get reliable 24/7 clean power. 2. You use that combo to build tough-as-nails microgrids for communities, hospitals, and factories that desperately need them. And 3, you go all in on local manufacturing to create jobs and grow the economy. It's just an incredible thought, isn't it? That something so simple, really, just some special liquid in a tank, could be the key that unlocks a future of energy independence, economic opportunity, and real, sustainable prosperity for millions of people. It's a pretty powerful idea to end on.